Today we are going to talk about finding the distance between points on an axis and the length of a line segment. Um, Now, for all of these only work if the points create a straight line. So if the points connect and have a straight horizontal line or a vertical line, these methods will work. So one more time, we've been talking about horizontal and vertical a lot because of our x-axis and our y-axis, but if you still aren't quite positive what horizontal is vertical, please add these to your notes for good measure. So when we talk about two different methods to find the distance, it has to be horizontal lines or vertical lines. It cannot be diagonal lines. That is a much more complicated formula, which involves using triangles to find the, I believe that's called the hypotenuse, which is something that you will do in a different grade level. So it will not work for diagonal lines. This is a method that will only work for horizontal and vertical lines. Okay, so now that we have that clear, let's look at what they give us here. First they say, consider the points -4, 0, and 5, 0. For our methods today and on your homework, I expect for you to sketch a rough sketch of what these lines will look like. As you get better and have more experience with the coordinate plane, it won't be as necessary to make these sketches because you'll be able to visualize them on your own. But for today, humor me and go ahead and sketch these so that I know you know what you're looking at. So by a sketch, what I mean is you would just draw a rough coordinate plane with the x and y axis. Then I would place -4, 0. So I start at my origin. Since it's -4, that tells me I need to go 4 jumps back to the left. And since it's 0, that tells me I don't go anywhere up or down. So it would be right there on the x-axis. 5, 0, I would start at the origin, move 5 jumps to the right, and since my y coordinate is 0, I go nowhere up or down. So now I can see a rough sketch of where these lie in the plane. So next it asks me, what do the ordered pairs have in common? When they say common, they mean what do they have that is the same? Just like when we say least common multiples, greatest common factors, those are what factors that they have the same or multiples that they have the same, to make some connections there. Okay, so what do they have in common and what does that mean about their location in the coordinate plane? Well, when I look at -4, 5, 0, 0, what they have the same is this part right here. They are both 0. And you should know by now that the second number in the ordered pair is called our y coordinate. So what do the pairs have in common? They have the same y coordinate. And it happens to be 0. What we notice when they have y as the same axis, or sorry, same coordinate, is it creates a straight horizontal line. So anytime you see two ordered pairs with the same y coordinate, you can visualize a horizontal line. So what does that mean about their location in the coordinate plane? It means they will form a horizontal line. So since it'll form a horizontal line, that tells us that our two methods would work for this situation. So it says, how do we find the distance between two numbers on the number line? Well, if I had two numbers on the number line, like -3 and 2, to find that distance, I could jump from this number to that number. So here it would be 1, 2, 3, 4, 5. That is method 1. Method 1 is to jump from one number to the next number and count the spaces. What we're really counting here is how many of those spaces, like how many blocks did I go from -3 to 2. I had to go 1 block, 2, 3, 4, 5 blocks. The other method is a little more complicated, but it uses a little more math and can be a little more efficient if you are doing bigger numbers. So the other method would be to find the absolute value of both of those numbers. So from -3 to 0, the distance is -3, but we want the absolute value because we don't care that it's to the left of the 0 or to the right of the 0. All we care is how far is it from 0. So remember that absolute value is always positive. So the distance from -3 to 0 would be 3. Then the absolute value of 2, again, I don't care that I went to the right or to the left, but how far did I go after I left 0 would be 2. And then for method 2, it is a little tricky because you have to decide, am I going to add those two absolute values together or I'm going to subtract those two absolute values. On the number line, if you cross 0, you need to add them because I need to take this space right here and this space to get the total space between those two. 3 plus 2 equals 5. When we come down here and do it on the coordinate plane, it'll be a little more clear how we know to add or subtract. So let's look at that. So now it says use the same method to find the distance between -4, 0 and 5, 0. So if I go back to my sketch here, and this is -4 and this is 5, I can again do my two methods. I can jump from -4 to 5. I have to put in the tick marks here. So -1, 2, -3, -4, 1, 2, 3, 4, 5. And so I can jump 1, 2, 3, 4, 5, 6, 7, 8, 9. And I can know that the distance is 9. The other way I can do it is to find the absolute value. So again, this is method 1. And this is going to be method 2. So the absolute value, how far is -4 from 0? It is the absolute value of -4. It would be 4 hops from 0. How far is it from 0 to 5? Again, the absolute value of 5 would be 5. Now, on the coordinate plane, since this horizontal line crosses the y-axis, it actually makes a plus sign with the line and that axis there. So that's our signal that we need to add those two pieces together to get our total length of 9. We'll look at some other examples, on our second section that'll show us when we need to subtract. So let's look at the next option. Our next option is consider the line segment with endpoint 0, -6 and 0, -11. Again, draw that sketch first so we can have a visual of what we're seeing. Since it's 0, -6, I don't go any direction left or right. I simply go down to -6. And then 0, -11, it is, I'm going to have to draw this a little bit further. 0, -11. I don't go anywhere left or right because my x-coordinate is 0, so I stay on the origin, and I have to go down -11. So I'm going to go past -6 down here to -11. What I notice is it again creates a line, but this time it is a vertical line. So what do the ordered pairs of the endpoints have in common? What do they have the same? Looking up here at these two, what do they have the same? In this case, hopefully you said they have the x-coordinate as the same. And what does that mean about the line segment's location in the coordinate plane? In this case, in all cases where the x-coordinates are the same, we are going to create a vertical line. And give yourself a visual for vertical one more time. Vertical lines, which makes sense because if I have 3, 3, and I have one up here and one down here, they're going to line up together and create that vertical 9. If I have -5, -5, they're going to line up together and create that vertical line. So to recap, when y coordinates are the same, it'll create a horizontal line. When x coordinates are the same, it creates a vertical line. So now they want us to find the line segment described by the distance between its endpoints for 0, -6, and 0, -11. So I'm going to use this sketch again, but since I know I'm going to be down here, I'm going to put my origin up top a little bit further, and then I'm going to call this -6, and down here is going to be -11, 7, 8, 9, 10, 11. So I have my two methods again. I can count my tick marks, 1, 2, 3, 4, 5, and I can know that these 2 points are 5 apart. So this line segment is 5 units long. Method 2 would be find the absolute value of each of these numbers. So how far is -6 from 0? And that's actually going to be this space right here. So -6, the absolute value would be 6. How far is -11 from 0? Well, that's going to be 11 spaces. So the absolute value would be 11. Now, think about it. Do I want to add this 6 plus this 11 here? I'm going to kind of color code that for you. Do I want to add this 6 plus this 11? No, because what I really want is this red part between here and here. So what I don't need is this yellow part. So how do I get, oh, I am so sorry, my camera is off. Technical issues today. Thank you for bearing with me. Okay, so what I did is this 6 is representing from 0 to here, and this 11 is representing from 0 all the way to 11. I don't need to add this piece plus this piece to figure out what that red section is. Instead, I need to get rid of this yellow piece, and I actually need to subtract it from this green piece so that all I have left over is the red piece. Again, method 2 might be too confusing for some of you, and that's okay to admit, and it's okay to go with method 1 and just to count the spaces in between. But if you are understanding this and you notice, this simply makes a subtraction sign. Up here, we had made a plus sign because it had crossed the axis, which told us to add both of them together. In this situation, it creates a subtraction sign, which tells us we need to subtract these two. So if I subtract 11 minus 6, and I get 5, which is the same thing I would have got with method 1. And it's okay if sometimes you want to use method 1 and sometimes you want to use method 2. That's fine too, to kind of mix it up and try either way. All right, that was the video for example 1. Next, we're going to go to the video for example 1 and 2. Next, we're going to go for our second page that should be in your math notebook for example 3.